Well, thank you. And thank you to the organizers for inviting me. I'm going to share with a couple of other speakers have said is that when I was first asked, of course it was an honor to be asked to speak at this, but I wasn't sure why me. And I'm thinking maybe the afternoon of day 2, Keith thought I might be mildly amusing and provocative, so I'm going to give that a try. So,
but you're confused.
I'm confused. I can be confused and provocative. So I had my talk put together, and I was missing a theme, and I found it yesterday in the talks, and it was really interesting. I think it was Dan who made the observation that we were talking about a threat. It was related to a service, and it got me thinking, especially with the work I do related to landscapes. If a threat doesn't involve a service, is it still a threat? And another version of that is, if it's a threat that we're unaware of, you think, well, because there's unknown unknowns out there, then is that still a threat? So let me take you through some really simple math. And of course, I'm going to go to my go-to position, which is fire. So if you take a look at historical Alberta and pre-industrial times, on average, ballpark is about 600,000 hectares burned a year. Okay? So if we take a look at the last 60 years or so, we exceeded that only 6 times, met up to 600,000 hectares. 6 times over the last, there was 5 there, but I didn't count 2017. So over the last 59 years, it's been 6 times. Okay, so Darren's slide actually, the cumulative age class distribution sort of, foreshadowed this. We've got a lot of older forests out there. I'm going to take a little bit of a different tack on this. Say, well, okay, but we've had fires, so the theory is we add fires to harvesting and disturbance, and then we're going to be okay, right? So is that the case? Not exactly. So let's do some back of the envelope calculations here. There's about, plus or minus, a couple of million hectares, about 50 million hectares of forest landscapes in Alberta. Okay. Now for context, and I think this is important to say now at the very least, if not at the start of the day yesterday, forest management areas in the province only account for between 20 and 21 million hectares of that. So just 40% of the forests. Okay. Of that, the areas that are actually working forest, where you can operate, vary from, in the LPAC area, it's down around 30-35%. In the foothills, we're up around 80 or 85%. Again, ballpark average is 14 million hectares. So most of what we've been talking about over the last couple of days is only a third of the forests of Alberta. So let's talk about the rest. So of that 14 million hectares, we know from the research that we've done that this sort of simple mathematical model here, we've got fire, we've got harvesting, we're about in the historic range. So in the working forest, this more or less plays out, okay? But only in that 14 million hectares. The other 38 is a different story, okay? So as an example, let's take the rest, the forested area, which is about 44 million of the 50, and spruce, black spruce leading is about 9 million hectares, again, depending on how you calculate it. Okay, so it's 20% of the forest out there. Now, who here, anyone, operates on black spruce? Does anyone take black spruce? So, okay, there's one. Okay, it's pretty rare. It's pretty rare that you're going to go into black spruce areas. So these are classic non-operating areas. We know from the work that we've done in simulations that because we've been quite fairly successful in forest fires, we have this, if we take a look at the amount of black spruce forest that's young, and young, let's say less than 20 years of age, historically, and this is across the whole province, I'm not going to go by ecoregion, we lump them all together, we end up with between 20 and 40% most of the time. Today, we have less than 5%. It's barely within the historic range, okay? So here's an example of potentially a unhealthy condition. Regardless of what you think of whether or not NRV is a good idea or a good guide, what we do know, or we have a pretty good idea, that over the last few thousand years, this landscape has had between 10 and 40, 20 and 40% of young black spruce. It probably almost never had 3 or 4%. Okay? And we're talking, this 30% here, the median, that's 3 million hectares. So it's 3 million hectares of a habitat type we don't have anymore, okay? Across the whole province. There's parts of the province where there's none, not just a little bit, there's none, okay? Do we not consider that to be a threat? Probably not, because one part of it is it's not the working forest. What's probably the ratio of research topics on working forest to passive forest is, 100 to 1? So we don't understand enough about it. What we do know is that those forests have successional stages. They have early successional species, just like the rest of the landscape. So potentially, we're talking about species that need young black spruce-dominated forest that aren't getting it. What species do we not know about that we can't even name might go extinct? The next the next cure for cancer, we don't know. We don't understand it, we can't name it, it's not a threat. Okay, let's talk about the part of the forested landscape that isn't forested. Non-vegetated part of the, or non-forested vegetated part of the landscape is, again, ballpark about 7 million hectares. It's a big chunk, okay? Now, if we just isolate the wetland part of it, open fens and bogs and grasslands, of course, we have no idea how old they are. We don't know how long it's been since the last fire. I can't tell you what these numbers are down here or what this relationship holds, but it's probably, again, the same thing. Now, is that a value that we should be considering? In the grand scheme of things, we're talking about a chunk of the landscape. Let's add the black spruce and the non-vegetated together. A third of the landscape that probably has at least as much biodiversity, because we're talking about wetlands, than the rest of the landscape. And by the way, it does have to do with climate change and fire. This is a picture of the 2014 fires from the Northwest Territories. Okay? That was a really interesting fire year, because typically what happens in wetlands is the top maybe 5 to 8 centimeters would be available for burning. When you get severe drought years, that drops down to 20 to 30 centimeters, and then fire behavior switches and bogs become wicks. They don't stop fires, they keep them going. So even if we end up with drought conditions like this once every 10 years instead of once every 20 years, it's going to have a huge impact on a huge part of the landscape. Forget about forests turning to grasslands. Okay? This could be a game changer as well. These fires, for anyone who's fought fires in a wetland, they're really hard to put out. They can go for years. The other thing I want to point out, if it wasn't obvious already, black spruce is caribou habitat. Okay, so there is some value there. In any case, so another question could be, another version of this is, what if the threat, those consequences aren't immediate? It's like, yeah, it's a problem, but it's going to be a problem down the road, so let's not worry about it. So I want to talk about coarse woody debris. We know about the value of coarse woody debris. There's been enough research on it. Huge relationship between woody debris and regulating water flows, a buffer for flooding, habitat, nutrient input, erosion control. Think about your favorite fishing spot on your creek or your river. It probably involves woody debris. It probably involves a big log somewhere holding back sediment traps, or an area where they're spawning. So we know the value of it. Now, how does woody debris get in the stream? Well, it comes from disturbance. So every time We have disturbance in this case, we're talking about fire. We do know from our research that after the fire, it takes anywhere from, some of it happens immediately. There's a pulse immediately that falls down. It can fall into or near the creek. And it can occur over, 20 or 30 years. But it takes time for that to happen. So where does the wood come from? When we talk about a fire cycle in a landscape, and in this case I just use an example of 100 years, it doesn't mean you get a fire every 100 years. Okay? So in this case, I ran it out 700 years on a little toy model, fire, 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 fire. And at each one of those you would get a pulse of woody debris. Okay? What really happens is you end up with, on average, at any one site, about a 100-year cycle, but it could be a long time. Oops. Fat fingers. There we go. Could be a long time between fire events, in which case you get a lot of very large wood. They could happen very close together. You get fires back to back. Happens all the time in the boreal, where you get a small amount of small wood, and then medium-sized wood. So you get this sort of smorgasbord of things going on. You have fires happening at different times in the position of where the stand is, creating wood of different sizes, and then it decays at different rates. And in here, there's sort of four accepted versions of what happens to woody debris. It starts out as a bridge, becomes a partial bridge, it breaks off, it becomes partially embedded, some of it gets carried down the creek. And these can happen over time, and when you actually drill into these pieces of wood using dendrochronology, we find some of these pieces have been here for 50 to 60. We found wood in the foothills that's been there for 100 years, and we could still drill it. Okay, so there's a long, there's a dynamic going on along here, but it takes a long time to play out. All right. So what do? Human influence here has had two impacts. First of all, fire control, and I'm going to talk about the foothills in particular from now on, has been very effective stopping fires. And the ground rules state that you must stay within or further away than 30 meters or 20 meters, or 30 meters seems to be the average, away from a creek, and no harvesting can happen. Okay? So no disturbance, no creation of woody debris. So we've got a situation over time where now the only inputs to the system would be occasional maybe windstorms or single tree dynamics. Eventually you're going to get a big fire every once in a while. It's going to create big wood. But at every point in time, what you're going to get is big wood. So of the wood that's in the stream right now, again, back to this idea of, is this a threat now? You think, well, we've got, this is sort of the natural range, we know, of the size classes, and this is what's happening now, so we know it's starting to shift, because we're not getting any wood. They're not getting any small wood from any sources, right? It's not coming from fires, it's not coming from any other source, so the small wood has stopped, it's decaying, it's disappearing, right? So we had this, it's disappearing, greater proportions of large wood, and the large veterans are starting to come down. Okay? So in 50 years, is this what we've got? And it might take 50 years. All that small wood is gone in the stream. We have no source for it, and all you're getting are the large veterans that are falling down in the creek. Now, what's the service that's being provided by this compared to that earlier one with all those different sizes occurring at different points and different times in the creek? Is this providing flood control? Is this providing erosion control? Probably not. It's probably a threat down the road. It's starting to become one now, but by the time this happens, it's going to be too late. We're already going to be having flood events that wouldn't have happened if we had had healthy amount and type and diversity of wood in the stream. So it's to the point where, and I'm sure some of you are already aware of this, Some areas in the US are actually putting wood back in rivers and streams because of this, because they reached the point where they didn't have any left. Okay? And so this is happening. So this is a threat, but it's not immediate. It's like, well, we can wait. Well, maybe we can't. So here's, a projection from one of our models of what might happen. A really nice, healthy distribution of the 4 stages, and into the future, not much of this, mostly big bridges. That's all we've got left. So, my take-home message is from this. A threat is not the same as an unhealthy condition. A threat is a human construct. It has to do with our values. Healthy landscapes don't have anything to do with human values. Those are ecological values. Do they overlap? Sometimes. Most of the time we hope so. But we can only identify it as a threat if we understand it or we can name it. And in a lot of cases, I've only given you 2 examples of things that are affecting massive areas of the landscape. I mean, we're talking about a third of the landscape that has no or very little type of a habitat anymore. Okay, you don't have to be an ecologist to think, okay, that might be an ecological issue, and it might come back to bite us one day. There's a pretty good chance that's going to happen. So landscape health is not a human construct. A threat is. Just because we have no knowledge of the potential negative impacts doesn't mean it's not a threat. Okay? What we don't know can hurt us, and we should be looking for these things. We tend to focus on the things that we can identify, that we have in front of us, and be reactive to. And then just because the threat may be years or decades into the future doesn't mean that we shouldn't be talking about mitigation now. Because by the time it becomes a real threat, if it's not one now, it's probably going to be too late in the case of woody debris. And with that, I'm done. Thank you.